do the homework?
So the one which you gave in the class, I did that, not the assignment.
Not the assignment? Okay, fine. So let us discuss this, okay? The assignment one. So I have given you a unit cell. I hope you can see the unit cell. That is the red part here, okay? The red triangle, it is the unit cell, and you have to calculate the Z, the relationship between A and R, and the packing efficiency So first of all, let me find the Z here, okay? So if you see the Z, so you tell me how many types of atoms are there? We have only one type of atom. All the atoms are in the corner. Yes or no?
Yes, sir.
Correct. Any doubt till here? Tell me, guys. All the atoms are in corner, right? All the atoms are in corner of the triangle, na? The unit cell.
Yes, sir.
Right. Okay. Now, how many atoms are such? How many atoms are like that in the corner of this unit cell? 3. Very good. So we have 3 atoms. Okay. Into what will be the contribution? The contribution, I have said that it will be equal to 60 upon 360, right? So this will be equal to, this will be 1 by 6. So you will get 3 into 1 by 6, and this will be equal to 1 by 2. So the Z is equal to 1 by 2. Next, we have to calculate the relationship between A and R. Okay. So relation between in this, you can obviously see that A is equal to 2R. Correct, all of you? No problem till here?
No, sir.
Hello, yes or no? No problem, na? Okay. Next, we will find the packing efficiency. Okay. Next, we will find the packing efficiency. So packing efficiency, it will be equal to Z into this. These are circles, right? These are circles. That is why this will be pi R square divided by area of the unit cell. What will be the area of unit cell? Tell me. What should be the area? This is an equilateral triangle now. So area of equilateral triangle is root 3 by 4.
A square.
Yeah, root 3 by 4 A square. And we know that A square A is equal to 2R. So we'll write this as Z, which is 1 by 2 into pi into R square divided by root 3 by 4 into A is 2R. So this will be 4R square. And then we can eliminate a few things. This R square, 4 and 4. And what we will be getting is pi upon 2 root 3. Okay, this should be into 100 because it is packing efficiency. Right? So tell me, what will be this value equal to? I hope you have calculated this previously also, na? 90.68 this will be equal to. Yes or no? All of you? Calculate this and see. It will be 90.68. Assalamu alaikum, Huzaifa. How are you?
Welcome, sir. Yes, I'm fine, alhamdulillah.
Okay. Try to be on time, hai na?
Yes, sir. I was a little late today. I'm sorry.
Khalil has also joined right now only. Okay, he got disconnected. He joined again. Assalamu alaikum, Khalil. How are you?
Welcome, Islam, sir. I'm fine.
Okay. Try to join in time. Okay, Khalil?
Yes.
Yes, okay. Achha. So I hope all of you have calculated this. Hishma, tell me. Hishma, Minashi, you guys were there. Yes, Hishma and Minashi, please tell me. Pi upon 2 root 3 into 100 will be equal to 90.68, right?
Yes, sir.
Now what I want all of you to see is that this unit cell is of a packing that we have already studied. If you see here, this was the unit cell, na? Yes or no? Tell me. This was the unit cell, right? Now this unit cell is of packing AB type. Hai? So what I wanted to prove is that even if I take the hexagonal unit cell or I take the triangular unit cell, we will get the same packing efficiency. So in packing efficiency, if I took the hexagonal one, I again got 90.68. So this just proves that if I study a very small portion, that is the unit cell, and if we repeat the unit cell and we can make the whole packing, if I study that particular small arrangement of atoms, then we are in fact studying the whole packing. Okay, so here on we will be focusing on the unit cell only. Okay, so you can see even if I take the hexagonal one or the triangular one, our packing efficiency is going to be same, but we are going to take that unit cell which I tell you. Why? Because usually you can be confused like which unit cell is the best one. The unit cell I see which is the best one is the one which gives you an idea about the coordination number, because packing efficiency we can always calculate, but the coordination number is a thing that you have to see and tell. Okay, you have to see and tell. Okay, fine. Next we have the other question. Identify the void in AAA type packing in 3D. I think if you look at the structure that we drew yesterday in the last class, sorry, you will say that it is a cubical void. Right, guys? Okay, so this will be a cubical void. Then I have put in a question for IUPAC nomenclature because I don't want all of you to lose the touch with organic chemistry. So let me just see the names that you guys have written and then move towards the next topic. Okay, where is Minashi? Yeah, so Minashi, this is not right. I think the first, okay, fine. What did you get it wrong? So you got Z is equal to half, that is fine. Then, okay, you got this also correct. But where did you get it wrong?
In the numerator, I multiplied with 3.
Denominator, why 3?
Yeah.
3 atoms you thought?
No.
Since we have like this? You thought that these 3 atoms would be there?
Yes.
What did you think? I can't hear you. Say properly, na?
Yes, sir.
तो याद नहीं आपको.
I thought 3 will be there.
You thought 3 will be there. Acha, in the formula only, you thought.
No, not in the formula.
Then, first of all, this is not right. Why 3 would be there? Why did you think 3 would be there? See, packing efficiency is, tell me.
Z into pi s.
Nah, space occupied by? Atoms in unit cell?
Number of atoms into space occupied of one atom.
That is correct. You can, in general, you can say space occupied by atoms in unit cell divided by space of unit cell. Na? So marks obtained divided by total. So this is my total marks. If I have one atom here, this is my marks obtained. And these parts are the marks detected, that is the void. Na? These are the void. So you have to see how much space is occupied by atoms and divide by the space of the whole unit cell. So this is the unit cell. You keep this in mind, okay? Space of unit cell. You keep this in mind, and then you will not do any mistakes. Okay, fine. Other things were fine. You just did this small mistake. Okay. Let us look at the. So what is the functional group here? It is E. Okay. Now the new student may find it a bit different from how we name how we name things. But functional group is E. Please bear with me. Okay, functional group is E. What is the next thing that we check? Minashi, Hishma, Mazia, and Khalil, you guys tell me for the nomenclature. Unsaturation, unsat. What is the unsaturation? En. Right? Yes or no? अरे खलील, माजिया, मीनाशी एंड हिश्मा, आप लोग बात कीजिए. पेरेंट, व्हाट इज द पेरेंट? जल्दी बताइए, पेरेंट क्या है? Pent. Very good. Pent. Okay. And after that, what do we look?
Function.
Functional group? Substituent.
Substituent.
Substituent. What are the substituent? So see, we are done with functional group unsaturations. We are done with this and these things, right? We have already taken care of these things. So whatever remains after parent unsaturation functional group are known as substituent. So we have Br as substituent and this Br as substituent. Okay, so we have dibromo. We have dibromo. Dibromo. Now we have to number it, right? We have to number it. So which terminal should I start from? A terminal or B terminal? Which terminal should I start from? A or B terminal? Hi guys, tell me. Kishma, tell me. B. Why B? Why B? What is the sequence? The sequence is, first of all, you will see, you will start with that terminal which has either the functional group nearest to it or the double bond or then the triple bond. This is the sequence now. Then only we will go to substituent and all. So you can see already that I will start from here 1, 2 because I will get the double bond in the second number, then 3, 4 and 5. So dibromo will be 3, 4. Pent and En will be 2. Okay. So you will get ये तो गलती कर दिया आपने. This is not right. देखिए Minashi, you see here pent na 5 carbon atoms. 5 carbon atoms and then you are saying 2 en. So 2 en will be like this. Then you are saying 2 bromo, 3 bromo. So this is the structure you are talking about. Okay. 1, 2, 3, 4, 5. देख लीजिए एक बार मीनाक्षी. This is the structure that you are talking about and our structure is a bit different, right?
Yes, sir.
है ना? Okay. So this will be 3, 4. Now my older student, those who have done IUPAC nomenclature with me, I wanted these things. Okay. So this will be 3, 4 dibromo, pent, 2 en. Okay, fine. Then I think you have not answered the last one. Okay, it's fine. Okay, cube nickel white, you have answered it. Very good. Okay, who else? We have Hishma. Okay. Oh wow. I mean, Hishma's handwriting is very nice. Extra marks gets you, sorry, extra marks. Good handwriting does get you extra marks, I think so. If I see this type of handwriting, even if Ishma has done something wrong here and there, I will just neglect it. Okay. So if you have a good handwriting, it really works for you. कहाँ है? लेकिन आपका आंसर कहाँ है? आपको मार्क्स कहाँ से मिलेगा? आंसर कहाँ लिखा आपने?
Sir, this is the first assignment.
This is the first assignment. Second assignment कहाँ है आपका? किया नहीं आपने ना? हाँ?
No, sir.
अच्छा, और सर ने वही को 2 बार पेस्ट कर दिया. सर ने को लगा कि आपने भेजा है. अच्छा चलिए कोई बात नहीं. Who else do we have here? Khalil, आपने भी नहीं किया assignment?
Sir, I did, but I submitted this note.
Okay, that is why it is not updated. And what about others? We have Mazia. Mazia, आपने नहीं submit किया है? Yes, Mazia, did you submit the assignment? No. ऐसे कैसे चलेगा? This is the start of 12th standard. You have to at least come in with a good positive energy, right? You have to come with that attitude. Na? We have got new books, we have got new copies, and we will be start doing something, right? So please, I hope you submit the assignments next time. Okay. Yes, and similarly, I have not got assignment from Huzaifa. Huzaifa, kya hua? Yes, Huzaifa.
Sir, I registered like yesterday, so it was showing something about 24 hours for it to sync or something.
Okay, fine.
Yeah, so I couldn't do it.
So you have Nishkash sir's number, yes or no?
No, I don't.
You don't have any number for Learnivio from Learnivio?
No, I think my father does. I can take it from him.
Please take that one number from father, whatever you're in contact with, whomever.
Yeah.
And ask him, sir, can you please send the assignment of 12th standard Middle East batch?
Okay, sir.
Chemistry. Okay, chemistry.
Yeah. Yes,
Right?
thank you.
Okay. So where did we end the last time? We ended with, okay, 3D packing. Okay, AA type packing in 3D. Fine. So I will borrow these things and take it to our today's class. So the coordination number is going to be fun. Okay, so coordination number is going to be fun. Okay. So void, I think all of you can see that it is a cubical void. Okay, this is a cubical void, and this is known as AAA type in 3D. Okay, coordination number I will mention it, but after mentioning the unit cell that we have. Okay, so what is the unit cell that we have here? So void में हमने void लिख दिया. This will be void. So the unit cell is simple cubic. Okay, all of you can see that. I hope everyone is in same page as me. Yes or no? Can I get yes or no? Ishma, Huzaifa, Khalil, Mazia, and Minashi.
Yes.
Yes, sir.
Okay, very good. Okay, very good. Now, all of you keep your mic on. We will find the coordination number. Coordination number of atom in the coordination number of atom in this simple cubic unit cell, or we can say coordination number of atom in our AA type packing in 3D. Coordination number. Okay. So can all of you turn your mic on? I will ask yes or no questions only. Okay. Yeah, Hishma, Mazia, and Minashi, can you please turn the mic on? Okay. All of you are sitting in a cubical or cuboidal type of room, yes or no?
Yes.
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 Okay. All of you are facing some kind of wall.
Yes.
Yes.
Yeah, if you look front, you'll have a wall. Okay. So can you point on the top left corner? Can you point on the top left corner? Yes or no?
Yes.
All of you can?
Yes.
Okay. Thank
Yes.
you. Now, okay. So if I want to show that top left corner, let me make that corner here. So let us suppose that this is the corner, and you have, let me make the wall first. So let us suppose that you are facing this wall, and this is the top left corner that you are pointing. Okay, and you are pointing at this corner. So obviously your room will be 3D, right? All of your room are 3D, na? Yes or no?
Yes.
So some effect I have gone and I've made this 3D room. Now this corner, okay? So there will be a room. There will be, if there is no room after your room, then please don't say, sir, mere ghar mein nahi hai. But you can assume that there will be a room adjacent to this room. Yes or no? Adjacent to this room, right? In which we will have this wall common, right? This wall will be common in both the rooms, the wall which I have made, right?
Yes.
Yes or no? Now, yes or no, Khalil, Huzaifa, Mazia, Minashi?
Yes.
Yes.
Yes. Yeah.
Okay, fine. And this corner will be common in both the rooms, right? Both the rooms will have this corner, correct?
Yes.
Right? Tell me, yes or no?
Yes.
Yes, they will have this corner. Now, if we are living in such rooms that they have rooms and similar rooms only, okay? You have similar rooms, then there will be two rooms adjacent to these two rooms. Yes or no? Tell me. There will be two rooms adjacent to that, these two rooms, correct? Yes or no?
Yes.
Right. So like this you have. Now we have made one floor, right? You can see that there are 4 rooms in one floor, correct? Can all of you see that?
Yes, sir.
And all of these 4 rooms will have this corner, correct? Yes or no?
Yes.
This corner will be there, at least this corner that we are talking about. Okay. Now, we have these 4 rooms in one floor. We have these 4 rooms in one floor. There will be similar type of 4 rooms in the next floor, correct? Which will have this corner also. This corner will be present in the above rooms. The room above this, first room, second room, third room, and fourth room. Yes or no?
Yes, sir.
Yes.
Right? All of you can see that?
Yes.
Right? Now, if I place an atom here, this atom will be shared in the 4 rooms of the ground floor and the 4 rooms of the above floor. Correct? Yes or no? Can all of you see that? If I place an atom, okay, that atom will be big enough, okay? Please remember that. We have atoms in the corner and they are so big that they are touching each other. You can see here that this is a corner in which we have this atom here and it is so big, right? It is taking half of the edge. Can all of you see that if I have an atom in a corner, that atom will be shared in 4 rooms? Yes or no?
Yes.
Yes. What about others?
Yes, sir.
Yes, that corner is shared by 8 rooms, and that is why if I place anything on that corner, that thing will be also shared by 8 rooms. Okay, that means okay, I think we should change this topic to, wait a second, Z. Okay, Z in simple cubic. Okay, so we have here atoms in all the corners, right? Yes or no?
Yes, sir.
In a simple cubic, we have atoms on all the corners, right? All the corners. Okay, so in Z, simple cubic, all atoms are in corner. Okay, now tell me, if this atom A is present in 8 rooms, then what will be the contribution in this one room? Tell me. This atom is present in 8 rooms. So in one room, how much of the atom is present? What portion of atom will be present in one room?
1/8.
Very good. All of you agree? Yes or no?
Yes,
Yes.
sir.
Right. So all atoms are in corner. We have 8 atoms, and their contribution is 1/8 in each cell. Right. All of these 8 atoms have a contribution of 1/8. That is why the Z in simple cubic will be equal to 8 into 1/8 will be equal to 1. All of you understood this? Yes or no? Z will be equal to 1. Yes. Huzaifa, Hishma. There are 8 atoms and each has a contribution of 1/8, and that is why Z will be equal to 1. Can I move on?
Yes.
Yes. All of you tell me yes or no?
Yes, sir.
Yes. Okay, fine. Now, I have to select a few things from here, and okay, this will be a bit tough to select the blue ones, right? Okay, let me take a portion of this. I want to find the coordination number. Okay. So I will look at one atom, that is the red atom here. Fine. Now this red atom is touching how many atoms? Tell me. In this one floor, how many atoms?
4.
4. All of you can see in one layer it is touching 4 atoms, correct? Yes or no?
Yes,
Huzaifa,
sir.
Khalil, all of you can see now.
Yes.
Yes, sir.
There will be one atom just above it, correct?
Yes.
Right? Blue atom. We'll place the
Yeah.
blue atom just above it. Now it is touching how many atoms? The red one?
5.
5. Okay. Then there will be also an atom just below this layer, below the red layer also. There will be some atoms, right?
Yeah.
Right. So we have now 6 atoms,
6.
correct?
Yes.
So the coordination number will be 6. All of you can see that?
Yes.
Yes
sir.
or no?
Yeah.
Right?
Yes, sir.
Yes, sir.
Coordination number will be 6. Now I will give you another way on looking at how the coordination number will be 6. Okay. So see, you don't have, do you have to remember this thing? Or if you just remember the packing, then it will be easy, right? You don't have to remember the coordination number will be 6. You can just derive it anyways. Coordination number will be 6. Okay. Now again, I'm giving you another way to look at it. So we have this one room. Here. Okay. So now I'm giving you an option. You have 8 atoms here, right? Let me count this. 1, 2, 3, 4, 5, 6, 7, 8. Now you tell me, you choose one atom and I will show from this structure also how the coordination number is 6. Choose one atom, anyone. जल्दी जल्दी but choose करने में इतना time मत लगाइए.
1.
1. Okay, fine. Let's start with 1. I'm erasing the others. Achha. I hope all of you know that we have minimized the structure of the atoms, right? Yes or no? Right? This is not the original atom size. You have minimized the atom size. Correct? Arey haan ya na to boliye.
Yes, sir.
Right? So this first atom, it is in touch with this atom. And it is also in touch with this atom. Correct? Yes or no?
Yes, sir.
Yes, na? All of you agree? Tell me, jaldi boliye. Huzaifa doesn't agree, I think. Huzaifa, 1 and 2 are touching each other, yes or no?
Yes.
Yes, na? Okay. 1 and 3 is also touching each other. 1 and 4 is also touching each other. Correct?
Yes.
Okay. Then there will be another unit cell like this. Correct?
Yes.
It will have some atom here. Now this is, I'm touching this atom also. Correct? There will be a unit cell backwards, and that will also have an atom. Correct? Yes or no?
Yes.
There will be some unit cell, na? It will be like this.
Yeah.
Right? And there will be a unit cell on top of it, and it will be touching an atom here. Correct? Yes or no?
Yes, sir. Yes.
There will be atoms like this, right? There will be unit cells like this that this will be touching. Right? So we have now how much? We have 4 in the plane again. You can see 1 on the top and 1 below. 4 in the plane. These 5, 6. So this line we have like this. So all of these are in plane. Then we have 1 from the top, and then we have 1 on the bottom. Okay. So we have coordination number 6. So you have got both the pictures, right? From the unit cell also and from the packing also. Okay. So the coordination number in simple cubic is 6. Coordination number is 6. Okay. Then we have relation between A and R. That is again easy to tell. A relation between A and R. Okay. So it's quite easy. So all of you can see now that since these atoms are touching each other, this will be the edge length A, This will be R and this will be R. So A will be equal to 2R. Yes or no? Tell me, guys. A will be equal to 2R, right?
Yes,
Because these two atoms are touching each other. Right? These two atoms are touching each other. The edge length is A, and then you have R and R. Okay. Fine. So we have got all the things. Now we will find out the packing efficiency. Efficiency. So packing efficiency is equal to space occupied by atoms in unit cell divided by total space of unit cell into 100, right? Now, what is the space occupied? It will be the number of atoms into the space of one atom. Divided by the total space of unit cell. Please don't write these things, okay? And tell me now, what is the space of one atom? What is the space of one atom? In this packing, what will be the space of atom? हाँ खलील बोलिए, हेशमा हुजैफा बोलिए, कोई भी बोलिए, जल्दी बोलिए. What will be the space? The space of one atom in terms of R. क्या हो गया? अरे यार, this is not good, huh? You guys are not speaking at all. हाँ खलील बोलिए.
Sir, 3D, right? So,
It's
4
3D.
pi r square.
4/3 pi r cube, है ना? क्या हुआ हिशमा, माजिया, मीनाशी? Why you guys are not answering anything? If you don't understand the question, please tell me that also. ना space of one atom से समझ में नहीं आ रहा क्या बोल रहे हो आप? Space of one atom will be 4/3 pi r cube divided by total space of unit cell. What is the unit cell? What is the shape of unit cell? Tell me.
simple cube.
Cube.
Cube. Okay. What will be the space? It will be volume or area?
Volume.
Volume. So what is the volume of a cube? What is the volume of a cube? If the edge length is A, what is the volume of a cube? ये भी नहीं पता.
A cube.
A cube.
Very good. Now, you have the value of Z, you have the relationship between A and R. I hope you can find out the packing efficiency. I'm giving you guys 4 minutes. If you want to copy something down, please let me know. Right? You can copy these things if you want, and then calculate the packing efficiency. Yeah, I've got one answer, I think. Okay. I think you're getting correct answer. Yes, Josefa. Yes, Reshma, correct. Like it's near, okay? Just wait for my answer because I will give you the answer that is by calculator. You must have been doing some approximations. Still waiting for other answers. I've got only two from Heshma and Huzafa. Waiting for Khalil, Mazia, and Minashi. Yes, Minashi, okay. Somewhat correct. Okay, Khalil and Mazia, you guys are calculating? Yes or no? Khalil?
Yes, sir.
Okay. Those who have calculated the packing efficiency, they can also write two more points. That is the packing fraction and the void percentage, right? So those who have calculated this, you can also write packing fraction is equal to how much and void percentage is equal to how much. Yes, Khalil, correct. Details, pictures, fine. Okay, so I think most of you have got the answer. It is 52.4%. Okay, so remember this 52.4%. Packing fraction will be 0.52. And what will be the void percentage, guys? 47.6, right? 100 minus 52.4%, which will be equal to 47.6%, right? So just write this down. Let me know if you're done. Then we will move on to the next packing. Please raise your hand if you're done. So the thing that you have to look in each and every packing and remember is that, first of all, what is the unit cell? Okay, unit cell you have to remember. Secondly, you have to remember what is going to be the Z. Third, we have to remember what is going to be the relation between A and R. Relationship between A and R. Then we have to know the coordination number, right? We have to also know the coordination number. Fifth is the calculate the packing efficiency, packing fraction, and the void percentage. Okay, so you can club these three things in the same point because all of these are related to each other, right? The unit cell for each and every packing that we are going to study, we'll study the unit cell, then we will study the Z, then we will study the relationship between A and R, then we will study the coordination number. And after that, we can study the packing efficiency, fraction, and void percentage. Is this clear with everyone? Yes or no? Yes or no?
Yes, sir.
Khalil? Okay, fine. Now, again, we started with 1D. Okay, after 1D, in this 1D, we have only one thing to remember, that coordination number is equal to 2. Then we went to 2D. So in 2D, we had two different options. What were those two options? Can somebody please tell me? What were the options? Yeah. Please tell me what were the options?
Atoms under atom and atoms under.
What was the name of this packing? Atoms under atoms. का नाम क्या था? Yes, AAA is atoms under atoms, right? And AB. Okay. Then what did we do? We took the AAA as the base layer. We took the AAA as the base layer and we went to 3D. So when we have AAA, then also in 3D, we have two different options. We can either get things now under atoms, atoms on atom, or atom on void. So we have already seen this atom on atom, and we have seen that we have got a packing which is AAA in 3D. And we have got the unit cell as, please remember the unit cell, it is simple cubic. Right? We have got the simple cubic. Now we will study atoms on void when we are having the base layer as the AAA. Okay, when we have the base layer, AAA base layer, then what is going to be the arrangement if I put the atoms on void? So I think I need to draw the AAA first. So let me. First of all, we will draw the whole thing, and then we are going to name the packing, right? Then we are going to name the packing. I really hate why do we have this type of circle which is transparent. Is there any way to ink inside the circle? I don't know. I don't want to waste the time now. So I will. Just wait a second, okay? Let me share my screen with something else. I think that is. Can all of you see this? Yes or no? Tell me, guys, can all of you see this?
Yes, sir.
Yes, okay. So this is fine. See, I like this type of balls, okay? And also because I can place them quite efficiently. So we have the blue layers like this. And I can just get it a bit above. Okay. So I'm starting with the structure that because I have forgotten how to use this. Okay, so this is our AAA type, right? And we have got 4 footballs on the floor. 4 footballs on the floor. Now, please tell me, I've taken another football and I'm placing on top of it. Okay, where did I place it? On top of the 4 footballs. All of you can see that? Yes or no? Please tell me. Yes or no? Okay. Now I hope you can say that as I will place this football on top of the 4 football, these 4 footballs will move a bit apart. Yes or no? Right? As soon as I place this, then they will move a bit apart. Correct? Yes or no? Tell me. I have extrapolated how much they will move, but you can see that they will move a bit apart. Correct?
Yes, sir.
Yes or no? Okay, fine. So I can move on. Super. Okay, so I will take the structure. And I will something like that. This is going to be no use if I waste so much of time in this. No use. Okay, and I'm placing atoms under atoms. Okay. This atom will be here. This atom will be here. This is my second layer. Okay. All of these are spheres. This is my second layer. Okay. So my second layer is done. Now I want to move on to the third layer. Okay. So I have placed the atoms on voids. Now again, we have got the second layer. And can you see that? Where is the voids of second layer? These are the voids of second layer, right? This is the void of second layer. Yes or no? Can all of you see that this is the void? Second layer किससे बन रहा है? Second layer is being made by these atoms, right? And here is the void, right? Arey, no. Huzaifa, Khalil. Guys, am I not audible? What happened? Tell me if you can't see the void. Okay, what is the color of the first layer? What is the color of the first layer?
Blue.
Blue. And in that blue, all of you can see that there is void. And I have placed the atom on the void. Correct?
Yes.
Yes, all of you? Okay. Now
Yes.
focus on the second layer. Focus on the second layer. The second layer is? What is the color of the second layer?
Red.
Red.
Red. Okay. You take 4 atoms of the red. Take 4 atoms of the red. Now can you see where is the void?
Yes.
Right? And we have to place atom on that void. Correct? So see, I'm placing that atom. Okay, this is my next layer, and I am placing that on the void made by the second layer. Okay. So you can see that, in fact, I am just placing a layer which is very similar to the first layer. Yes or no?
Yes, sir.
Right. So again, we can say that we have a layer. The first layer is, this is going to be our A layer. This is going to be our B layer. And this is going to be again our A layer. Yes or no? Because the third layer and the first layer, they are going to be completely same, right? All of you can see that, I think. This will be AB type. Correct?
Yes, sir.
Yes.
Okay. Okay, fine. So let me just take this thing and I have to be on the OneNote only. Okay. So we have got now the name. So write the name as AB. Type in 3D. Okay. Now let us look at the unit cell. How are we going to make the unit cell? The unit cell is going to be very easy. We'll take the blue one first. Okay. So in the lowest layer, the first layer is the blue one. So we have blue atoms like this. Make 4 blue atoms. And just on top of the 4 blue atoms, like in the center, we have a void and we have a red atom there, right? So I can see that these are the blue atoms and there will be a red atom here somewhere. Correct? Right? There will be a red atom here somewhere. And then again on the next layer, we will have the blue layer. We have the blue layer here. Blue layer on top of here. And blue layer on this blue layer will be somewhere here. This blue layer will be somewhere here. We have got can you see that there is a cube and with the cube which has in corners the blue atom and the red atom is in the body center. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
The red atom will be in the body center of this unit cell. So this unit cell is known as body centered unit cell. It's known as body centered unit cell. Now we have got the unit cell. We have seen the packing also. Now, first of all, what are we going to you now tell me? We will first of all start with the units. Then we will go to the Z. Okay. Then we will go to the Z. So let us calculate the Z of this body centered unit cell. The A part. Oops, let me not write A. Let me write the first thing that we will calculate is the Z of BCC. Okay. This is BCC, body centered cubic. Body centered cubic. Okay, BCC. Now, Z of BCC. So in the BCC, we have how many types of atoms? Tell me. We have 2 types, right? One is inside, and there are some atoms which are on the corner. Correct? Yes or no? Tell me, guys. There is one inside the unit cell, and there are how many are in corner? Inside one will have the contribution 1. How many are in the corner? Tell me.
8.
Okay, now Mazia, Minashi, why are you not speaking? I think you can see 8, right? Mazia and Minashi.
Yes, sir.
Yes, sir. So speak, sir. Corner. How many in corner? Tell me. How many in corner? Mazia, Minashi. अभी तो बोलिए. हाँ, बोलिए.
8.
Very good.
8.
What is the contribution of each?
1
What is the
by
contribution of each? 1 by 8. All of you remember this? The corner one, they have the contribution 1 by 8. Yes or no? All of you remember, right?
Yes.
So this will be equal to 1 plus 1, which will be equal to 2. Okay. I hope no one has issue why this is 1. Hai na? There is one atom and its contribution is also 1. Yes or no?
Yes, sir.
All of you understand this, na? Yes or no, bhai? All of you understand why this is 1?
Yes, sir.
Yes, sir.
Okay, thank you very much. Thank you very much. So Z is equal to 2. Next, what do we have to find? The relationship between A and R. Okay, relationship between. Okay, let us do one thing. Let us find the relationship between the relation between A and R. So for relationship, you have to remember the word atoms touch, right? All of you remember, you have to see this atoms which are touching each other. Yes or no? Yes or no?
Yes, sir.
Yes. Okay. Now you tell me, are the blue atoms touching each other? Are the blue atoms touching each other?
No.
No, na? The blue atom
No.
is not touching each other. Now, very carefully tell me. Very carefully tell me. This red atom. Okay, this red atom is on top of this atom. Okay. That means this red atom is touching the A atom, correct?
Yes, sir.
Yes or no? Okay. Then again, this B atom, that is blue atom, this is on top of the red atoms, and that is why B atom is touching this red atom, correct?
Yes, sir.
Yes or no? Okay, very good. Then we can make a line like this and say that these atoms are touching each other, and we will calculate the relationship between A and R using these atoms, Okay. So now, as you can see, what are these atoms? These are these atoms. If you want to plot it on the unit cell, you will get that these atoms are the ones which I am talking about. Yes or no?
Yes.
Correct? Right? These are the atoms which are touching each other. The red one is on top of blue ones and the blue one is on the top of red one. That is why these are touching each other. All of you can see that? Yes or no? Please tell me.
Yes, sir.
Right? All of you can see that. Okay, fine. So all of you also should know, this is the body diagonal. Correct? Right? This is the body diagonal.
Yes.
What is the length of body diagonal? If the edge length is A.
A√3.
Very good. A√3. अच्छा. यहाँ पे I want to ask Huzaifa. Huzaifa, do you understand how will you calculate A√3? Yes or no? Tell me. How this body diagonal is A√3? Do you know, Huzaifa? Huzaifa नहीं है क्या क्लास में? Yes. Okay. Fine. If you know this, okay, then it's fine. This is A√3. That means this length that I have drawn here, this is A√3. And this length from here to here, it will be 1R. And from here to here, it will be 2R. And then again, here to here, it will be R, right? Now we have the relationship between A and R. We have the relationship as A√3 is equal to 4R. Okay, please remember this. In body-centered cubic, A√3 is equal to 4R. Any problem till here in Z and relationship between A and R? Any problem, guys?
No, sir.
Any problem? No, no? Okay, very good. Now we have to know the coordination number. This is going to be fun. Okay, fine. So we, in this particular unit cell, how many type of atoms do we have? We have two types of atoms, the one in the center and the one in the corners, right? Yes or no, guys?
Yeah.
Tell me.
Yes.
Right. Okay. Now we have to prove that for both of them, what is the coordination number? Okay. What is the coordination number for both of them? Now, I hope for the red atom, okay. For the red atom, you can see that the red atom is on top of, the blue atoms in the lower layer. Yes or no? Yes or no, guys?
Yes, sir.
Right. Now, that means it is now touching at least 4 atoms. And it should also be touching the 4 atoms above it. Yes or no? Tell me. The red atom, it should be touching the 4 atoms in the top, right? Yeah, nahi?
Yes.
Yes.
Right. See, this is this red atom here. This red atom, it is touching this blue atom. This red atom, it is touching this blue atom and this blue atom. There will be one more blue atom here. There will be one more blue atom here. And this red atom will be also be touching those 2 blue atoms, right? So for the red atoms, we have seen that it is going to be how much? It is going to be what will be the coordination number? 8, right? 4 in the lower layer, 4 in the upper layer, correct?
Yes.
I hope all of you can do that. Okay, fine. Now you tell me one thing. All of you will tell me one thing. This blue atom, all of these blue atoms, these are touching the red ones, yes or no? All of the blue atoms are touching the red one?
Yes, sir.
Okay, this atom, this blue atom is in how many unit cells? This blue atom is in how many rooms? Tell me that. This blue atom is in how many rooms? It is shared in how many rooms?
4.
काहे का 4? अभी तो आप लोगों ने बोला 8 rooms ना, इसलिए 1/8 होता है. Why 4? 8 ना? 8 ना? हिश्मा, हुज़ैफा, माजिया, मीनाशी?
Yes, sir.
नहीं, हिश्मा आप बताइए, आपको दिक्कत है 8 में? Hishma, can you speak, please?
Yes, sir.
Do you have any difficulty in understanding why this atom is shared in 8 rooms and how
No.
this atom is shared? No?
No.
For sure?
Yeah.
Explain. How 8 rooms? Explain how 8 rooms.
So on that layer, there will be 4 more unit
सीधा 4
cells.
नहीं होगा. नहीं, सीधा 4 नहीं कीजिए. Start like this, okay? So this atom is in at least one room we can see, right, Hishma?
Yes.
Then it will be in the adjacent room, right?
Yes.
So now we have 2 rooms. Then the atom which I am picking here, this one, this will be in this room, that is the adjacent one. Then these 2 adjacent will have 2 more adjacent in the back of, like in their back. So this atom will be shared now in 4 rooms. And all of these 4 rooms will have a top floor. And those atoms will also be sharing this particular atom. So start with 1. We have 1 room, and then on the adjacent, now we have 2 rooms. Then these rooms will also have a room in front or in the back, however you're choosing the atom. Now we have 4 rooms. All of these 4 rooms will have 4 more rooms above, and that is why we have 8. Okay. Now, in all of those 8 rooms, Hishma, there will be a red atom.
Yes, sir.
And if this atom is present in 8 rooms and there are red atoms in all of these 8 rooms, this atom will also be touching all the red atoms. Yes or no?
Yes, sir.
All the 8, right? That is why you can see that this red atom also has the coordination number 8 and this blue atom also has the coordination number 8. Okay. So coordination number is 8. Red is touching the 8 corner atoms. Okay. So red is in body-centered atom. Okay, let me write body-centered atom. BCC atom is touching the 8 corner atom, and the corner atoms are touching red atoms in all the 8 unit cells. In which they are present. Okay, in which they are present. Fine. So we have gone these 3 things. Z, you have also seen the unit cell, relationship between A and R, coordination number. Then we will do the packing efficiency. Please write this down. Raise your hand if you're done. Raise your hand if you are done. Raise your hand if you're done. Okay, if you want me to scroll up, please tell me. Okay. Did you guys think about Ramzan time? What time will be suitable? Yes, Hishma, Huzaifa, Khalil, Mazia, Minashi. हाँ guys, what happened? किसी ने नहीं सोचा अभी तक. We're waiting for Hishma, Khalil, Mazia. Just waiting for Hishma now. Okay, everyone is done. Okay, next is packing efficiency, right? It's occupied by atoms in unit cell divided by space of unit cell. Okay, so space occupied by unit cell by atoms in unit cell, it will be equal to the Z into 4 by 3 pi r cube, because it is a sphere, into 100. I am missing the 100. A space of unit cell, it will be again equal to a cube. Okay, so I think all of you know what is Z here. Z is equal to 2 into 4 by 3 pi r cube divided by a cube into 100. We also know that a root 3 is equal to 4r. So a will be equal to 4 upon root 3r. So we can substitute that. We can write this as 4 by root 3 r whole cube. So just calculate this, send the answer in chat, then we will move on. We have got an answer. Yes, I think that is correct. I've got only one answer till now from Josefa. So Josefa, you also write the packing fraction and the void percentage. Next things. Okay. And also I will mention here what is the void in this particular structure, even though it is not there in NCERT. Okay. So you can just write that it is distorted octahedral. But no one will ask you this, okay? No one will ask you this. But focus more on this answer. You are getting quite high answer. Don't write this. I think you are near, Minashi. A bit high, but you are near. For others, okay, yes, Josefa, yeah, correct. Okay, you're again, Khalil, yeah, quite near. Looking for a few more answers. Yes, yes. So you can remember that it is 68%, okay? This is going to be 68%. It is approximately 68.03 or something, but packing efficiency will be equal to 68%. Packing fraction will be 0.68, and void percentage, it will be equal to how much? Please calculate and write that down, okay? Yeah, 70. 30, 32. 32% will be the void percentage. Okay, please write this down. So Zafar gave the answer first. Okay, so can you see this image? Can you see this image, guys? Right, okay. So what type of packing is this? Can you tell me? What type of packing is this that we have seen? Tell me fast.
AA type packing.
AA type packing in
3D.
3D, right? This is AAA type in 3D. Okay. So this type of structure, okay, this type of structure. Now, what we are showing, this is not the real picture, right? Because we have shown the atoms as points. We have shown the atom as points. So this is known as crystal lattice. Okay, so crystal lattice, this is known as this type of structure, this picture, or this type of picture, right? It is what? It is known as crystal lattice. So you write one statement and then you'll end the class. Crystal lattice. So crystal lattice, what is this? It is the depiction of 3D arrangement of constituent particles. That means the atoms, right? Particles. Later on, you will see that it can be ions also, okay, or molecules also. 3D arrangement of constituent particles of crystalline solids as points. Okay, as points. Now, each point in crystal lattice represents a constituent particle. Represents a constituent particle. Okay. So just write this down. Let me know if you're done. And then we have seen what happens if I put on another layer. That means if I go from square closed packing, that is AAA type in 2D to 3D. If I put atom on atom and atom on white. Next class, we will look what will happen if I put atoms, and if I want to prepare a 3D arrangement from hexagonal closed packing, that is AB type in 2D. So I want to go from AB type in 2D to the 3D arrangement. Okay, so please write this down. All of you are done? Yes or no, guys? All of you are done with this crystal lattice?
Yes, sir.
Yes. Okay.